Hello, and welcome to the National Spectrum Consortium Spotlight Series. I'm Maren Leed, the Executive Director of the consortium, and the Spotlight is a series of conversations that we have with member companies in order to help highlight their capabilities and broaden awareness across the consortium. We have taken to doing these in times when we haven't been able to get together personally, and look forward to when we're able to do that again. But in the interim, I'm very pleased to be here with Tony Triolo, the director at Perspecta Labs, one of our member companies. So Tony, welcome. Great to have you.
Thanks for having me on, Maren.
So before we dive into some of the technical areas that we'll cover, can you just tell me a little bit about what your day job is? What do you do at Perspecta?
Sure. So I'm a director of wireless and optical research at Perspecta, which will become Periton Labs. We've been acquired and changing our name, so I just wanted to let people know that.
Great.
So I've been in wireless technology for many years, more years than I'd like to mention. But at Perspecta, I'm director of a laboratory where we do wireless and optical research, things like advanced signal processing. And we look to solve some of the DoD's hardest problems by bringing some of that research into other areas where we can develop technologies that can exploit some of those things that we're doing there.
Right. Well, I know one of the areas that you've been involved in through us has been with a number of our 5G related projects. So can you talk a little bit about the work that Perspecta, now Periton, is doing in that area?
Sure. So we have 3 projects ongoing that relate to 5G in the Tranche 1, funded through the Tranche 1 project areas. The first one is a spectrum sharing effort where we're looking to maximize network throughput in the 5G network where it coexists with a radar system. So these are airborne radar systems that are the incumbent in that spectrum. And the 5G networks are looking to use it when the radar system is not on. So we do things like try to maximize network throughput by looking at the key performance indicators that are available through the 5G system, and take those key performance indicators, maximize them to the extent possible when the radar system is there, while trying to avoid interfering with the radar system. So that's one project. Another one is related to IoT security within a 5G network. So one of the projects is a smart warehouse in San Diego, Naval Base San Diego, where they're looking to modernize and bring things like smart tags to the inventory and add things that would make the operations of those warehouses more efficient. But one of the problems that comes with that is the security of those devices. They're very small devices. It's hard to include lots of security protections on them because it would bog them down to the point that they wouldn't be useful, or the processing resources on them are not great enough to do that. So we're doing something where we're using localization information about where the tags are, which is enabled by some of the features in 5G, like wider bandwidths, combined with embedded security design. So taking these little processors and adding security concepts to them that don't weigh them down too much. A third project is where we're looking at vulnerabilities in the 5G spec, also related to smart warehouses. If you're going to use 5G in some of these locations, you don't want to be vulnerable to someone breaking into the network or over the air doing something that would exploit the use of those devices. So we're taking some of the work that we've done for DARPA and bringing it to this project for 5G smart warehouse.
Well, that's great that you're diving into the security aspects, definitely at the forefront of the national conversation about how to best implement these technologies. So, and I think you're also at the edge of some of the logic behind our movement from the original Spectrum Other Transaction Agreement, which was really focused on some of the sharing issues that you talked about in your first project, to the Spectrum Forward other transaction agreement, which we were awarded last December, which is pushing more into 5G and related beyond technologies, as well as getting more into some of the contested and operationally relevant use cases for the Defense Department. So can you talk a little bit about some work you might be doing in those areas?
Sure. So yeah, contested environments are tough and very different than the typical environments that you would experience, say, for the 5G work, right? It's contested environment is something where you'd have lots of interference. 5G networks don't experience that kind of interference since they operate in licensed spectrum. So some of the areas that we're looking at as far as contested environments include something called Blue Force signature management, which means the soldiers that are in a unit carry lots of radio devices. They have things that are called end user devices that look a lot like cell phones, and lots of other radios. If a commander asks them to turn off so that they can go radio silent, how do you verify that all of these things are turned off? They have no real way to do that today. So that's one of the areas that we're looking at, which involves how do you do very wideband spectrum sensing, because a lot of these devices operate in very different bands. And as you go to 5G, you start including things like millimeter wave bands in addition to some of the lower bands. So how do you do spectrum monitoring for that Blue Force signature management in a way that's inexpensive and low swap? So we're looking at techniques like wideband optical devices at the tactical edge. So trying to reduce the swap on some of those devices, including cost, so that they can be used for this very wideband sensing. So that's one area. And then once you have these very wideband sensors, what do you do with the data that comes out of them? If you're monitoring something like 20 gigahertz of spectrum, how do you handle the processing of that data and make sense of it? So we're doing things like machine learning techniques to try to make sense of this very wideband data and do things that can enable you to classify signals, detect what's there, the salience of you have all of this noise. If you've ever looked at a spectrum analyzer across that wide of a band, there's a lot of things going on. How can a machine take that and make sense of it? So that's a very challenging problem. And then once you make sense of that, how do you mitigate things like interference from either intentional or unintentional emitters? If someone's trying to jam you, how do you mitigate that in an effective way over a wide band? So we're looking at things like array processing and using electro-optical devices to increase the bandwidth and enable the mitigation of that interference so that operations can still continue in contested environments. So those are just some of the challenges. There's many more.
Yeah, and they're all sort of exactly what I think the Defense Department had in mind that needing to solve as they try to implement the electromagnetic spectrum superiority strategy, and they're sort of fundamental to being able to execute joint all-domain command and control as they try to move forward operationally. So it's terrific that you're taking on some of those things. Can you just tell me a little bit about what your experience being a member of the NSC has been like for Perspecta and what you found useful or not so much?
Sure. Yeah, it's been great. We have several programs going on, as I mentioned earlier, and all of them are with non-traditional defense contractors, which we would not have met a lot of those if it weren't for the NSC and all the events that the NSC has held over the years. In previous years prior to COVID, we were able to get together and have some of these events where we could network with some of those companies that we wouldn't typically be exposed to. As a large traditional defense contractor, we typically work with other large traditional defense contractors, and we don't have a whole lot of exposure to some of these smaller companies that bring some great technologies. The events that even virtual events have been great. Some of the speed networking events to see what other companies are out there as members, what they bring to the table, and how we can work with them. And so on all of our NSC efforts, we have non-traditional contractors on there, and they've been doing a great job for us. And it's been great even beyond those NSC projects, because now we know these people at the small companies, and we're able to work with them on other things outside of the NSC as well. So that's been great for us, and we're very glad we're a member at this point.
Well, it's great to hear, because that really is a key part of the value proposition of the other transaction agreement, and how it's structured, both beneficial to the commercial side, but also bringing more value and different kinds of ideas into the government applications space as well. So it's great to hear that that's been a plus for you, and that we've been able to maintain it at least to some degree in this environment. And like I said, look forward to being able to further expand back out into doing more in-person things in the near future, we hope.
Yeah, that'd be great.
So you started to allude to the other work that you do at Perspecta. So can you talk a little bit more about how the NSC work fits with other initiatives that you have?
Sure. Yeah. DARPA is one of the other areas outside the NSC where we have a lot of work going on. They're one of our biggest customers, but the work there is usually, the typical DARPA high risk, type of work, moonshot kind of things that result in technologies that are lower technology readiness level. So, we typically do that kind of work to develop new technologies or new techniques that we can then bring to other work that we are involved in. The NSC work fits in because these are more deployable or higher TRL level projects where, you're looking to develop a prototype of something, and you're working with people who are the end customers of the prototype, people that will be using this thing, which is great because you can interact with them, you can ask questions, you can figure out what their use cases are, how they're going to use the technology. So the NSC work allows us to do these more near-term deployable, higher TRL types of things that feed off some of the lower TRL stuff that we've done in the past that has a longer time frame. These are projects that we've had going on with DARPA for many years. We can take some of that technology and bring it into what we're doing here in the NSC. For instance, the security work I was talking about earlier came from some of the DARPA work we've done on embedded security for IoT devices. And so we've been able to use some of those things in the NSC work. And then in addition to being near-term deployable and working with end customers, a lot of the NSC work is dual-use focused, which helps us to have a broader impact other than just produce a prototype for DoD. We're able to have this dual-use focus on some of the projects, not all of them, and then have this broader impact with the technology that we're developing, which it's a very valuable thing.
So are there specific examples of some of those dual-use things that you've been able to work on?
Sure, yeah. One of the projects that we have done through the NSC, this was early on, was the Cellular Range Telemetry Network, which was a project where we were trying to take COTS cellular equipment. At the time, this was, I think, awarded in 2016. It was LTE based. So we took commercial LTE devices and we added an applique to the front of those. So just a standard chipset from a handset, typical handset, and added an applique to that handset device in order to compensate for the Doppler that would be induced when you're testing a high-speed aircraft, so a supersonic aircraft. So we were able to deploy a network to Edwards Air Force Base and do flight tests with that technology, where we were able to fly the aircraft with our Doppler compensated applique along with our ground network, which does things like doing a directed handover to cells that have the minimum Doppler as the plane flies through the area. So we developed all of that for DoD test case use, but it's also equally applicable to commercial use cases. We've had several commercial aircraft manufacturers talk to us about using it for testing their aircraft instead of the traditional telemetry systems that they use, which are dish-based, and they're pointing and tracking dishes that follow the aircraft. They would be able to deploy a network like this and use it both on the ground and in the air, and use the spectrum more efficiently, since you get the advantage of using a commercial system that's evolved over many years to be really spectrally efficient. So it enables you to have this lower cost, spectrally efficient use of commercial technology, and use it both in DoD applications and in commercial applications. So it's been a very good program, and we're actually another effort was just released. An RPP was released through the NSC to take that technology and shrink it into a lower swap and lower cost unit that can be used in cockpits of things like, the F-16, where there's limited space. So yeah, it's been a great project, and the fact that it's dual use only makes it more valuable to us and the broader technology community.
It's a great range of activities that you're involved in. Sounds like it's keeping you busy for sure.
Yes, very busy.
Well, I appreciate you taking time out of your day to talk with me today. And if anybody has any questions for either you or me, please feel free to reach out at any point. But thanks so much, Tony, for taking the time.
Yeah, no problem. I've enjoyed it. Thanks.
Thanks.